Let's continue and let's talk about the low-level clouds starting from Stratocumulus cloud, meteorological code SC. As seen in the picture, this is a gray or whitish patch or sheet of layered clouds which almost always have dark tessellations or in honeycomb appearance. It has rounded masses or rolls except for virga, and they are not non-fibrous or may not be merged. They also have regularly arranged small elements with an apparent width of more than 5 degrees or 3 degrees at arm's length. So this apparent width of 5 degrees, it's the formation of these stratocumulus clouds on the surface or at a certain altitude of a 5 degrees in the atmosphere. So except for its virga is the streaks or visible streaks of precipitation that is coming from the stratocumulus clouds. But sometimes this virga may or may not merge because this is a kind of stratocumulus. This is also another form of stratocumulus clouds wherein from the appearances of cumulus clouds that is detached, but you can see as a stratocumulus cloud, it has a layered type of appearance. As you can see, the appearance of cumulus clouds, it has some rounded appearance of a cloud that is resembles the cumulus cloud, but it is a lowest, or it has a low altitude and appearing as a layered form. That's why it is a stratocumulus cloud. And the stratocumulus cloud produce no precipitation, and when they do, it is generally only light rain or snow. However, these clouds are often seen at either the front or tail end of the storm or a worse weather. So they may indicate storms to come in the form of thunderheads or gust of wind. So when we see this formation of a stratocumulus clouds, that is a layered cumulus clouds, we can say that, okay, there is a storm to come, and we can experience, or we may expect that they will have a gusty wind or gusty weather. Stratus cloud. So this is a generally gray cloud layer with a uniform base, which may, if thick enough, produce drizzle or ice prism or snow grains. When the sun is visible through its cloud, its outline is clearly discernible. Often, when a layer of stratus breaks up and dissipates, blue sky is seen. So we can see some layers of stratus cloud in a vast amount of stratus clouds that is developing on the sky. Sometimes we will have an overcast stratus cloud, but some streaks of sunrise can seen in the fragments or in the holes of this stratus cloud. This is also another variant of stratus cloud wherein we can see the sun is peaking on the spaces in between the clouds, and sometimes appearing as rugged sheets of stratus clouds that do not produce a halo phenomenon except occasionally at very low temperatures. So this is also a variant of stratus clouds. So they often produce precipitation that is usually light to moderate. Okay, only light to moderate rainfall is the precipitation or the weather associated with the stratus cloud. Next, the very famous cloud, cumulus cloud. As we can see, it is a towering clouds that is resembles to a series of cotton balls. Sometimes it can appear as a cauliflower or sometimes a head of a broccoli. Okay, so this is a cumulus clouds. These are detached and generally dense clouds with sharp outlines that develop vertically in the form of rising mounts, domes, or towers with bulging upper parts, often resembling a cauliflower. The sunlit parts of these clouds are mostly brilliant white, while their bases are relatively dark and horizontal. This is another variant of a cumulus cloud wherein over land, cumulus develops on days of clear sky and is due diurnal convection. It appears in the morning, grows, and then more or less dissolves again towards the evening. Cumulus indicates fair weather, often popping up on bright sunny days, though if conditions allow, cumulus can grow into towering cumulus congestus or cumulonimbus clouds, which can produce showers. Okay, so when we see some detached clouds or some low level clouds hovering above us, in a white and detached or some like forming into a puffy cotton appearance or in a cotton balls appearance, we can say that that oh, there is a fine weather today or there is a fair weather today. But when it develops into cumulonimbus clouds, we have to be worried because it will produce or it we can say that there is a storm coming or there is already a storm in the area because cumulonimbus cloud is also known as the thunderstorm cloud, and this is a heavy and dense cloud in a form of mountain or huge tower. The upper portion is usually smooth, fibrous or striated, and nearly always flattened in the shape of an anvil or bust plum. Under the base of this cloud, which is often very dark, there are often low rugged clouds that may or may not merge in the base. They produce precipitation which sometimes is in the form of virga. So again, a virga is a visible streak of precipitation that seems like or looks like that the clouds is falling. Even the clouds are falling. So in the picture, you can see below the clouds or below the formation of the cloud, from the boundary of the land, we can see a very dark shadow or very dark area. So we can tell that that is a virga or a visible streak of precipitation or a very violent or heavy rain. So for example, you are living in the province and you are outdoors and there is a cumulonimbus cloud and it's having a precipitation of heavy rain, you can hear it from afar that the rain is coming. This is also another variant of cumulonimbus clouds, wherein, as what I have said a while ago, a virga is an observable streak or shaft of precipitation falling from a cloud that evaporates or sublimates before reaching the ground. A shaft of precipitation that does not evaporate before reaching the ground is the precipitation shaft. But in the form of cumulonimbus cloud, this virga in the form of rain is visible from afar. And we can expect that if we will have a cumulonimbus cloud, we will have or we are having already a storm because this cloud is associated with extreme weather such as a heavy torrential downpours, hailstorm, lightning, and even tornadoes. Individual cumulonimbus cells will usually dissipate within an hour once showers starts falling, making for short-lived heavy rain. Another type of clouds or a miscellaneous type of cloud is the Cumulus congestus cloud. So this is another genus of a cumulus or another type of cumulus clouds, wherein cumulus congestus clouds, also known as towering cumulus, are a form of cumulus clouds that can be based in the low or middle height ranges. They achieve a considerable vertical development in areas of deep, moist convection, and they often bring light precipitation. So this is cumulus congestus clouds. This cumulus congestus clouds is associated with the development of a tornado or a waterspout that is also known as the funnel clouds. Funnel clouds is commonly generated from cumulus congestus cloud and cumulonimbus cloud. It produces tornadoes and waterspout as it goes down the surface carrying devastating whirling winds. So as you seen in the picture, funnel cloud is also known as tornado. At that at the top of the funnel clouds, or at the top of the tornado, or the anvil of the funnel cloud, is the cumulus congestus. But at the lower part of the cumulus congestus cloud, there is a funnel clouds, and the funnel cloud is, we can say, it has a violent whirling wind that can devastate or destroys anything that comes to its path, being a tornado at land and waterspout at the sea surface. This is another variant of a funnel cloud, wherein this is a cloud of condensed water droplets associated with a rotating column of wind and extending from the base of a cloud but not reaching the ground or water surface. So as you can see in the picture, this type of funnel cloud have a devastating or violent whirling winds as seen in the picture of rotating clouds. Okay, but don't worry, these clouds does not reach the ground. It is only, for example, some like an altitude of like a level of low stratus cloud, some like some 500 meters above the ground, or one kilometer above the ground. This is chastened or watched by storm chasers, but don't worry, for us in the Philippines, this will not happen here. Usually it happens in the States. Next is the orographic clouds that is developed in response to the forced lifting of air by the Earth's topography or a mountain. The lifting of moist air can result in the generation of clouds, while lifting drying air may not produce any clouds at all. So orographic clouds are the product of the anabatic wind from the lecture of local winds, wherein at daytime warm air rises at the top of the mountain, and it will develop an rising air up of its slope, but it will leave behind some moisture and it will form in the form of orographic clouds. Next is a lenticular cloud. So lenticular clouds are stationary clouds that form mostly in the troposphere, typically in perpendicular alignment to the wind direction, and they are often comparable in appearance to a lens or a saucer. Where stable moist air flows over a mountain or a range of a mountain, a series of large-scale standing waves may form on the downwind side. If temperature at the crest of a wave drops to the dew point, moisture in the air may condense and form lenticular clouds. Next is sea fog. Sea fog is a form of stratus cloud, and this forms when warm, moist air moves over colder water and cools it to its dew point temperature, causing the air to saturate. The extent of the cooler temperature near shore waters and wind direction over that area affects the density and duration of sea fog events. So the occurrence of fog, as what we discussed in relative humidity and dew point lectures, it is from the formation of the saturated air. So that is sea fog. Another variant of the sea fog is the Arctic sea smoke. As you can see in the picture, so Arctic sea smoke is a smoke forming over small patches of open water in sea ice. It forms when a light wind of very cold air mixes with shallow layer of saturated warm air immediately above the warmer water. So it happens on the only on the Arctic regions and Antarctic regions wherein the sea is covered in ice. So for example, if the sea surface, the temperature of the sea surface is at negative 10 degrees Celsius, and if the air above it passes with a temperature of, for example, is a zero temperature, it is still relatively warmer compared to the temperature of the sea surface. So when it happens, the Arctic sea smoke or the sea smoke will occur. Next is the contrails or the clouds that is formed when an airplane passes or when an airplane hovers the sky. Contrails. So what is a contrail or the anatomy of a contrail? Contrails form as moisture in the air condenses and freezes around soot particles in the engine exhaust. In certain conditions, contrails can spread and merge, forming thin cirrus clouds covering thousands of square miles. They can persist for hours and warm the atmosphere. So that is a contrail. Contrail are the particles that is produced when the moisture in the air from the moisture from the soot engines of a jet or an aircraft or an airplane is condenses and forms in a cirrus clouds. So these contrails are a formation of cirrus clouds because as we know, airplanes do fly below the tropopause, which is at around 33,000 feet, and cirrus clouds form at high altitudes. So these airplanes makes additional cirrus clouds, and the formation of these contrails are adds to the warmth of the atmosphere, or it warms the atmosphere. So this in the information in the slides are from the National Oceanic and Atmospheric Administration or NOAA under National Weather Services. Also came from Wikipedia and from a book of Meteorology for Seafarers third edition with some information from Meteorology and Oceanography book written by A. Agustin and D. Antojado. Again, this is second mate Melvin Casanova, your instructor in Meteorology and Oceanography 1. Thank you.